Today we have section 11.4, areas of regular polygons. All right, we're going to go right to the vocabulary here. So here we have a shape inscribed into circle P, and that shape is a pentagon. So we have the center, which is right there. We have the radius, and the radius will always go to a point on the shape. For example, the pentagon, it'll be there at point A. That is the radius of the circle. Okay, then we have a new vocabulary term called apothem, and the apothem, I'm going to zoom in here, is this line right here. So it's not a radius. You'll notice it doesn't go all the way to the edge of the circle. Okay, but the apothem is perpendicular to the side of the shape, and it also bisects the side of the shape as well. Okay, last vocabulary, which you should know, is the central angle of the polygon right here. And the way that we find that is we take 360 divided by the number of sides. So for example, for a pentagon, we take 360 divided by 5, and some of you might be taking out your calculators now, like myself. 360 divided by 5 equals 72 degrees is the center angle. You'll see why that's important in a minute here. Okay, so here's some vocabulary. It says identify the center, a radius, an apothem, and a central angle. Okay, so if we have a square, okay, the center is K. I'll highlight that. The radius, we can say kg is the radius. Put an R there. The apothem, we'll use a different color, is KL, small a. Central angle, okay, all we do is we take 360 divided by 4, and we get 90. So that, use the highlighter here, this angle right here is 90 degrees. Okay, I think we found everything we needed to find. Okay, so make sure you know that vocabulary. Okay, moving on to a hexagon, we can see the radius here. We can see the apothem there, RS. Okay, R is the center, the central angle. Okay, now we have a hexagon which has 6 sides, so 360 divided by 6, and the central angle, which I'll highlight here, is 60 degrees. If you guys can find all that, you'll be in great shape. Okay, so I'm going to do this the long way, okay? But what we're going to do here is we're going to use some formulas that you already know to solve the area of this pentagon. I'm going to redraw this triangle, which we're going to do for a lot of the shapes that we have. Okay, and then here's my 90 degree. Okay, it says that the side is 2.5, and it says that the apothem, which is here, is 1.7. So area, here's a little review. Area of a triangle is 1/2 base times height. So we're going to find the area of this triangle, and then we're going to multiply it by 5, because if you look at a pentagon, which I'll draw one up here real fast. If you look at the pentagon, which that was a horrible drawing, but you have 1, 2, 3, 4, 5 triangles there, and we're going to find 1, 2, 3, 4, 5. We're going to find the area of one triangle and multiply by 5. Okay, so I'm going to put a multiply by 5 out here. So that's going to equal 1/2 times the base, which is 2.5, times the height, which is 1.7. Sorry, I'm getting jammed in the corner here, times 5. If you multiply all that out, 0.5 times 2.5 times 1.7 times the number of triangles, which is 5. Rounded to the nearest tenth, you should get 10.5 feet squared. So for area, we always use like square feet, square centimeters, square inches, whatever it might be. Okay, so that's the long way to do it, actually. There's actually a shorter way to solve these. And here are the letters to make sure you know what's what. S is side. S is side. A is apothem. And capital P is perimeter. Okay, so those are the 3 numbers we're going to need to solve the area of these polygons. Okay, and here's our equation. I will highlight it. Is 1/2 times the apothem times the perimeter, which is essentially the equation we did before. 1/2 times base times height times the number of sides. Okay, but this kind of simplifies the equation. So 1/2 times apothem times perimeter. All right, so let's try it out. Here's our first shape. So area equals 1/2 apothem times perimeter. Okay, so do we have perimeter? Well, we know that each side is 10, right? It's a pentagon, 5 sides, 10 times 5 is 50. Okay, so I'm going to erase all those. So P, perimeter, capital P, equals 50. I have to find A. Okay, so this is kind of a 2-step problem. Actually, more than that. What I'm going to do here is I am going to draw our triangle right here. I know that this is bisected, so this is going to be 5. 10 divided by 2 is 5. I'm trying to find A. Okay. Now, I don't have anything else. However, I can find an angle. So if you guys look back over at the pentagon, I can draw a line there. I can find my central angle. 360 divided by 5 equals 72. So 72 is this whole angle here. If I cut that angle in half, then I know that this angle is 36. And now I have my triangle to find some trig. Okay, so I know that this side is opposite of 36. And I know that this side is adjacent. So opposite over adjacent is tangent. Tangent of 36 equals 5 over, I'll put A for the apothem. Okay, what I like to do is put this over 1. And And I'm going to erase this here. So I have room 5. Once you cross multiply and eventually solve, it's 5 divided by tangent 36 equals A. So in my calculator, I'm going to do 5 divided by tangent of 36 equals 6.88. Okay, so that is the apothem. So all we do now, area equals 1/2 times 6.88 times 50. 6.88 times 0.5 times 50 equals, and I get 172 square inches. Here's my answer right there. Okay, so I have to use trig because I don't have the angles to find my apothem. Okay, and I took this triangle here and I wrote it bigger over there. Okay, let's try another example. Okay, here I have an octagon. How do I know that so quick? Well, the count of the sides, it looks like a stop sign. Okay, so my equation, area equals 1/2 apothem times perimeter. I'm going to do the same thing I did on the other shape. I'm going to go a little faster this time. Perimeter is 80, 8 times 10. Okay, central angle is 360 divided by 8, which is 45. Okay, so now here's my triangle. Here's my triangle. It's 5 again down here. Apothem, right? I could draw that there for you. Okay, I need to find the apothem. And I knew 45 divided by 2 is 22.5 for that angle right there. So once again, I'm going to do tangent 22.5 equals, because I have opposite and adjacent here, 5 over A. It turns out that the apothem, sorry, I mispronounce that sometimes, is 5 over tangent 22.5. So I'm going to type it into my calculator. 5 divided by tangent of 22.5. Nearest tenth is 12.1. So area equals 1/2 times 12.1 times 80. And that will equal 484 inches squared. Okay, so we need to find the central angle. We need to find, so that we can find this angle, we need to take 10 divided by 2 to find this side. And now we just find the apothem. We already found the perimeter over here. We just plug everything in. Okay, Now, here are some shortcuts you guys can use if you find this. Okay, here's a hexagon. And what you'll notice with the hexagon is that the central angle is 60 degrees. I cut that in half to find my top angle, and that's a 30. So now I have my 30, 60, 90. This is 5 root 3. That's the apothem. But now I need to find my perimeter. I need to find my side. Well, if you guys remember your 30, 60, 90 right triangles, this is now a 5. So if that little part is 5 and that's 5, the whole side is 10. So the equation would be area equals 1/2 times 5 root 3 times the perimeter, which is 60. I'm not going to solve all that right now, but that's how you would set that up. Okay, once again, we're going to use our shortcuts. I'm going to take this out here. I have a square. I know my central angle is 90. I split it in half. I get 45 here. I'm going to erase this so we don't get confused. Okay, I split 15 in half. I get 7.5. And then to find the hypotenuse of a 45, 45, 90, it's 7.5 times root 2. Okay, but guess what? To find the area, all I have to do really, and some of you probably caught this already, is to do 15 times 15, because that's an area of a square. Okay, our last one here is a pentagon. Okay, guess what? I don't need to know the central angle. I already have the apothem, 7.5. And the perimeter, 10.9 times 5. 10.9 times 5 equals 54.5 times 54.5. Sorry, it's a little sloppy. But if you already have that, you don't have to do trig. You can just solve. So those are kind of some shortcuts that you can use. All right, that's it for 11.4. Please ask questions. This is a little bit of a challenging section, and we'll talk to you soon.